I'm really sorry. There is some internet issue, so that's why I got offline. So let's continue our notebook. We have done. You can say we filled 9 values with a medium in you can say an income column. So now let me do df dot info for getting more info about our data frame. So here you can see we have 28 you can see unique column names. We have year, birth, education, marital status. Let me do one thing. We will you can say print unique values for you can say all your object data type. Let me do for you can say call in df dot columns. What it will what we have to do if call dot d type. Let me do one more thing. Df of education dot d type if oh I'm sorry for call in df dot columns if call dot d type is equal to you can say O, then what we have to do, we have to print the column name and the call dot oh I'm sorry we do not we cannot use just call here we have to give df of df square bracket call then what we want to print df of call dot unique. So this will get print all unique values. Then we want to just do df of code dot unique, and here we want to print just a unique value inside the you can say inside that column. So let me run this command. So we have one education column. Oh, I'm sorry, I forgot to write len here. So here you can see in education column, we have 5 unique values that is graduate, PH, Masters, basic and second class. Then in marital status, we have single, together, married, divorced, widow, alone, you can say absurd and YOLO. And then in you can say date customer, we have you can say all dates. We have 6, you can it is 663 you can say dates. Okay, so we can do one thing. We can drop this DT call customer. Let me drop this column. What's the column name? It is DT underscore customer, and axis will be equal to 1 and in place is equal to true. Here we can give drop in dt customer dt customer column. So now what we will do, we can perform one before doing one hot encoding. We can do visualization also, or we can or we first you can say. So in this project, we do not perform visualization. We directly perform. We directly try to, you can say, we will try to train our model, and we will do visualization later. So here you can see. Also, let me do one more thing here. Let me just, for my information, for just information purpose, let me just check the unique values in all columns. So here you can see in teen home we have just three unique values, and in kid home we have just three unique values. Also in complaint column we have just two, and in Z cost contact we have just one unique value. So let me just see Z underscore cost contact you can see. So we have just that is in all columns we have just three. So if we use this column as independent variable in our model training, so it will you can say negatively affect our model. It just increase dimensionality. It has no use in training our model, because it has you can say similar value for all our data points. So that's why we will drop this column, and also Z revenue column. Let me also check what's inside Z revenue. Revenue. Here you can see we have just 11 for all our you can say data points. And let me also check what's inside this response column. Response dot unique. So here we have just 1 and 0. So actually this is our you can say target variable, and all these other are just features. So now we were just dropping df of you can say Z cost contact and Z revenue. So for that, let me do df dot drop. Then this time if we this time we have two, you can say two column. So that's why we have to give our value inside a list, and then we have to mention the column names. So one is Z underscore cost contact, and other is Z underscore we have to give this in a string format, Z underscore revenue. Then our axis is equal to 1, and in place is equal to true. also mention. Let me do markdown here. Dropping Z cost contact and Z underscore revenue column because it because these columns have only one unique value. Now what we will do, let me check what's inside these. You can say complaint accepted and accepted camp 2, camp 1, camp 3, camp 4, camp 5. DF of. Okay, then it should be unique. In my opinion, it should be 1 or 0. Yes, here you can see. So now let me perform, you can say, one hot encoding. Let me, we have done a tf.info. So let me check all data type. Here you can see we have int object. For that we have to do one hot encoding also for that. So we already removed DT customer column, so we do not need to worry. All other columns are integer value, and this one is float value. There's no worries. Okay. So we have to, you can say, do one hot encoding for these two columns. One is our education column, and other is marital status column. So for one hot encoding, we will use pd.getDummies performance one hot encoding on which column? It is marital status and marital. It should be, I guess, it should underscore. Let me cross check. It is, yes, it is you can say underscore. Then we have education column on education and marital status column. DF of edu. So for and say this, you can say one hot encoding in a variable name ohe pd dot get dummies. For that our data is hey, we have to give our column names, that is and we will give this in the list df of one is our education and another one is marital status. Then x is equal to Or we do not need access. Let's see. Let me check OHE. Oh, so this is giving mean true and false. So I have to, you can say, change the this to integer value. For that, we have to use as type int. So now this for true it converted into one, and for you can say false it will give value as 0. And also I want to drop first column. So for that I there is one subject called drop first, and we have to give this as true. We have to give this true. Here you can see we got our one hot encoded value. We have 11 rows. I'm sorry, we have 11 columns. Here you can see. Now what we will do, we will concatenate this data with our, you can say, with our DF data frame. But we will drop from DF column, we will drop our education and marital status column. So let's go. Let's do this. And before that, what we can do, and that we do it later. So I want to create a heat map of our, you can say, correlation matrix, how our all other, you can say, all our features are correlated with our feature variable. I'm sorry, with our target variable. Now, what we can do, uh, we can trying to concatenate. So let me define, you can say concatenate data in df column. Let me do df pd.concatenate. What we have to do, we have to give a list. Here we want to concatenate one hot encoding with, here you can say df. Let me for df write for df write my command here df dot drop, and here I will give two columns, that is education, and another one is marital status. And now I will, you can say, give the command axis is equal to 1, and in place, yeah. Oh, so we do not need to do in place equal to 2. Okay, we have to give this. I'm really sorry. Here you can see we get our all numeric columns. So we will copy this command here, and now we will how we have to concatenate. We have to concatenate x is equal to 0. Let me do df. Oh, I'm really sorry. We have to give x is equal to 1. So we have to, oh, we saved in df. So we have to, you can say, run entire whole code again. So here you can see we get our data with 34 columns. In so we have 23 plus 11, it is 34. Let me remove this cell. Now let me create correlation matrix. Correlation heat map So for you can say finding correlation, we have df dot core method. Here you can see we get correlation. Let me save this in core variable. And for printing heat map, we have df dot heat map, and then we give our data core, and we give annotation is equal to false because we have huge correlation. You can say we have a very high number of variables. That's why what we can do here, we can give title phd dot title correlation heat map. Oh, we forgot to do phd dot show. Here you can see. So for blue means it is these columns are very high, very highly negatively correlated. So we can find no, income column has a very high negative correlation with numweb visits month. Let me check. df of income, and other column is our numweb visits month. Numweb visits month. Okay, I'm very sorry. Why they giving me error? df dot columns. df of income, and it is numweb visits month. Let me. The above exceptions were the direct cause of following exception. Here you can see we get our results. Let me find correlation. So it is around 54, or you can say 55, 0.55. So it is not highly correlated. If it is around, you can say 0.9 to 1, or you can say minus 0.9 to minus 1, then what we will do, we can drop one column from these two columns, because for as the both are correlated, so we need to drop one column, because it will create you can say that another column will be useless, or you can say it will just increase the dimensionality of our model, nothing else. So let me just take TF off. So we have core. Here let me select our feature name, you can say target variable name. It is response. Here you can see. Let me sort this value. Sort values ascending is equal to false. Okay. Before that, what we have to do? We have to do absolute value here. So this will convert all values into, you can say, positive values, all negative values into positive values. Here you can see complaint is around 0% correlated, and num deals purchases also, you can say, 0% correlated. So with the, you can say, with the domain expertise, we can remove these columns. So let me just take top 10 columns. And then we will train our model using just top 10 columns. For that, let me save this in a variable name code as core, and let me do response. Then, oh, I'm sorry. Now we are just taking top 10 values. Core. Here you can see we have just top 10 values, and then we will do dot index. Here we get the just column names. So for we will create a new data frame. df1 is equal to df of, and we will give our this core underscore response dot index value. So in our df1, we save just these columns, these 10 columns. Let me show you. Dot add. Here you can see we have just 10 columns, 3, 3, 6, and 4 10. Let me perform a here scaling also. And before scaling, what we will do, we will split x and our independent variable and dependent variable, or you can see we split our features and target variables. Splitting independent and dependent variable. Oh, we should give this in header form. And for independent variable, I will use x, capital X, df1 dot row. We want to use here, you can response comma x is equal to 1. Let me show you the x. Here you can see we get our value. Now for y, what we will do, y is equal to df1 of response. Here you can see we get our value. Now what we will do, we will split for it, split x and y for training and testing part. Let me get this in a heading form. Splitting data to training and testing set into training and testing set. So for that we will use a train test split. Before that we need to import the train test split. So it will be in scikit-learn library, scikit-learn dot module selection. We need to import our train test split, and then we have to xtrain, xtest, ytrain, and ytest is equal to train test split. And one more thing, as this is our classification problem, so we have to check is our you can say data is balance or not. So for that we will use df dot value counts. Here you can see our data is very highly imbalanced. Here, as you can see, for 0 it is around 900 rows, and for you can say response 1 we have just 300 you can say rows. So we can do one more thing. We have to for balancing our data set, we will use smart. We will create a dummy values for column 1. So let me do, as our data is imbalanced, we will use smart technique for balancing our data. So now let me write here smart. Let me check from Google where it is smart. I think it should be in IM balance like that. You can see it is in IM billion oversampling smart from IMB learn oversampling. But we have to import smart. I guess first we have to define the smart. Smart is equal to smart. So we have key neighbors. Okay. We have to use fit resample. Okay. Let me give some random set. Our random set will be 21, and now we'll do x balanced, comma y balance is equal to smooth dot fit resample, and we have to give our data y comma yeah, you can x comma y, Let me check here. Y underscore balance dot value counts. Here you can see our response are balanced. We have, you can say, for one also we have 1906 unique unique data points. So now we will split our data into X-train, X-test, Y-train and Y-test. And we will split X underscore balance, comma, Y underscore balance. And our test size will be 0.2 so that our testing size is 20% error. Our training size will be 80%. Our random state will be 21 and we will do stratify is equal to here you can see we will give y underscore balance. So what's the use of stratify? It will split you can say this will use to split our data in the same ratio as our data is split in here you can see in y balance. Let me show you. Here you can see if I will do here y test dot value counts, then we have you can say equal number of 0 and 1. Here you can see we have you can see nearly equal number of 0 and 1s. So now what we will do, we will import our random forest classifier and try to train this model. Train our model using random forest classifier for for a random forest classifier, we do not need to scale our X and X, here you can say X train and X test. But like for you can say logistic regression and other models for you can say for bagging models, for boosting models, we need to you can say we need to scale our model. We need to scale our X train and X test. So let me train our model using random forest classifier. First, we have to import our random forest from scikit-learn dot ensemble. We have to import our random forest classifier. Then we have to define forest is equal to random forest classifier forest dot fit. We have to give our x train comma y train here. Then we have to do we need to find accuracy score. For finding accuracy score, we will use a dot score accuracy score forest dot score, and we have to give first x test value, and then we have to give y test. You can see we are getting 87% accuracy, but we cannot in classification model we cannot judge our model using accuracy score, we need to see what's the precision score and recall score, or you can say F1 score. So let's create confusion metric first, then we will create you can say classification report. So before that we need to import our classification confusion matrix from scikit-learn dot it was in I guess metric, yes, matrices, import classification, not first we have to import confusion matrix, then we have to import our classification report, then we also need to create a ypred variable where we will save our predictions of our x test. Let me use clf dot. Also, my model name is forest. Forest dot predict. I want to predict my values for x test, and then I will create confusion matrix for confusion matrix, and I will save confusion matrix in my cm variable. Is cm is equal to confusion matrix, and then I have to give y true, that is my y test, and after that I have to give my y pred value. Then I can do one more thing. We can create a heat map for confusion matrix. So I will do sns dot heat map, and I will give my data as cm, and I will do annotation is equal to true, and I will also create it. I'll also mention a title here, that is confusion matrix. Confusion matrix heat map. Let me do plt dot show. Here you can see. Let me do one more thing. Change this. You can say change this format. So for that we have variable as fmt. Here you can see fmt is equal to so here you can see we get a nice heat map. So now we'll create a classification report. Classification report. So for that we will just print classification report, and first we have to give our y test value, and then we have to give y pred value. And you can see we get our nice classification report in which our for 0 our precision is around 0.89, and for 1 our recall is 0.89, and for 0 our recall is 0.85, and for 1 our precision is 0.86. And for both 0 and 1 we have one score as 0.87 and 87. which is nice. We can hypertune this model also. So let me do one more thing. Let me do it for you can say sport vector machine. Uh, for that we need to scale our model. Let me do standard. Let me do standardization. Standardization. First, I have to import sklearn from sklearn dot pre-processing import standard scalar, and then I have to you can say define my standard scalar. Then x trend uh, yes, I will. You can say save this in extent. So first I have to do. I have to you can say fit my scalar. Using x train, and then I will transform x train and x test. So for that I have to use scalar dot fit underscore transform for our x train, and then I have to mention x test is equal to scalar dot transform x test. So now let me run this. You can see uh, now let me show you xtrain. You can see our data is transformed. So training our model using SVM. So for training using SVM, you can say sport vector machine. We need to first import our SVM from sklearn.svm. We need to import SVC, which is a sport vector classifier. And then we have to define this SVM is equal to SVC and SVM dot fit x. Here you can say x train comma y train. Then let me do svm dot predict, not predict. So we can do all in one cell. Let me do ypred is equal to svm dot predict for x test, and also we can do svm dot fit no sorry, not fit score. So for accuracy score, or we can do just we will do this, and here we will write accuracy score. Then we will do svm dot score. Here we have to give x test comma y test. Here we are getting around 73% accuracy score. So but let's check our classification report. Classification report print So this time we do not need to, you can say, import our classification report because this module is already imported. Y test, comma, y spread. Here you can see we are getting nice recall score, but our you can say precision score is not that great as compared to recall score for 0, and recall score for 1 is you can say less for uh, you can say less as compared to precision of 1. So we can not train our model using logistic regression. Train our model using logistic regression. Let me again copy this code and paste it here. So our logistic regression model is in scikit-learn dot linear model. What we have to do is we have to import logistic regression. We have logistic regression CV model also. So here CV means cross validation. So this will you can say give me this will give me the you can say or give me the values, or you can say model with the cross validation. So here you can see we will get our model already as hyper tuned model. So we do not need to again hyper tune this model. So let me do a logistic regression, or you can say CV. Let me give this as CLF. Again here CLF, and then I want to predict using CLF. Let me run this. Again, I want to create accuracy score. Also, I want to create a classification report. Now let me just copy this code. And here our model name is CLF. So here you can see we are getting around 72% accuracy. Here you can see. So I think this is enough for today. Let me just save this on GitHub. Git add, git commit day 1, and let me push this to my repository. Okay. So I will see you tomorrow. Thanks for watching.